By now, you understand that the main purpose of programming is to solve problems. Now, to solve a problem, we process different rules, different formulae, we do various calculations in our programs. But it's not like that we write all those programs and we keep them aside. We use them, and to use them, we always need some set of data, some set of input data, and based on those input data and the main logic that we have written in our program, it produces some output data. So data always plays an important role in the world of programming. And when we talk about data, all the data are not of same kind, same nature. Like if we say 10, if we say 10.45, if we say C, all these are different type of data. So whenever a programmer is processing data through programs, he or she should be aware of what kind of data is getting processed. Even the compiler also doesn't accept every data same way. Compiler is able to differentiate between different types of data. So along with data, data types also plays an important role whenever we are writing a C program or any program in any language. C has provision of several data types. So whenever a programmer is writing a program, he or she should be aware of what kind of data will be processed through that program. And accordingly, program has to select suitable data type as per the need. Now, whenever we want to process some data, those data actually in our programs are processed through some variables that we know. And when we use or when we want to use variables, they should be declared along with their data type. And whenever we are declaring their data type, then some space in the memory is allocated as per the data type. And how much space is allocated, that we will see little later. So whenever we are declaring the data type for any variable, it decides that what could be the minimum value that it can accept as data, or what could be the maximum value that particular variable having that data type can accept. So the data type always decides the permissible range of values that it can accept, or the memory requirement for that particular data type. Now this requirement of the memory or this permissible range of values for that particular data type, it's not fixed. It will vary always from compiler to compiler or from machine to machine. And what is that range, that we will see little later. ANSI C supports 4 classes of data types. They are primary or fundamental data type, user defined data type, derived data type, and empty data type. Now the scope of today's class is only primary or fundamental data type. I will talk about user defined data type in our future class, and I will talk about derived data type when I will discuss about arrays, functions, or structures or pointers. Regarding empty data type, I will discuss in the class of functions. The primary or fundamental data type has many types, and among them these 4 are main types: character, integer, float, and double. And for every data type, whenever we are declaring a variable, the syntax will be same. Like for character, we will first write this keyword char for character and then the variable name, and that should be terminated or followed by semicolon. And we may declare multiple variables in the same line if they are having the same data type. Like here in the second line, var1, which represents variable 1, var2, var3, var4, since they are having the same data type, which is character, so they have been declared in the same line, separated by comma, and then finally terminated by semicolon. Then after we declare the any variable along with its data type, sometimes we may need to initialize with some initial value. And for that, what we can do, we may initialize after declaration and before we use that variable in the execution part, or in the declaration part itself along with the data type, we may initialize that variable. As you can see in the third line, status, that is one variable whose data type is char, means character, and we have initialized that variable with this value capital Y. And one thing we need to remember, that whenever we are assigning some value in the program, and if that data type is char, then we need to provide that value within single quote. And this data type char always accepts single character data. Now the second variable, gender, that also has the same data type char. That's why they have been assigned or declared in the same line separated by comma, and there itself we are assigning the initial value that may change later, that may not. And since this is not a symbolic constant, this is normal variable, so there will be always a provision that at the later point of time we may change the value of that variable, that we cannot do for symbolic constant. Now this is another main type of data type, which is integer, and that accepts integer data. The syntax is same. For integer data, first we write the keyword int, then the variable name, and again then terminated by semicolon. We may declare multiple variables having same data type in the same line separated by comma, and in the same line along with declaration we may assign some initial values also, as we have seen for character. And since this is integer data, we are not providing this data within any quote. The next important data type in C programming is float, and float is what? It accepts decimal data. So the keyword is float, and then the variable name, then again semicolon. And if we want to assign some value, then that we can do again in the declaration part. So this variable, which actually means minimum balance, and that has been assigned this value where before decimal point we have 100 and after decimal point we have 00. Then after decimal point, how many digits we will have, that depends on what data type we are using, that I will discuss later. Then the fourth important data type is double, which is same as float, only difference is in the precision. Precision means how many digits it accepts after decimal point. And again the syntax wise or declaration is same. So here the keyword that we use for data type is double, then the variable name, then semicolon. Then if we want to assign some values, that we can do in the declaration part itself. And here as we can see, it accepts more number of digits after decimal point. The main difference between float and double is, for float after decimal point the compiler accepts 6 digits, and for double it accepts 15 digits after decimal point. But it may sometimes vary from compiler to compiler, but each compiler will support the precision for double at least same as float. Now we know that whatever data we are entering from the outside, from using keyboards or whatever, be it decimal number system, octal, hexadecimal, be it integer data, be it float or character, but computer finally understands only bit stream. It only understands binary data, means only a series of 0 and 1. And we know in case of binary number system, if we are dealing with single digit, then single digit can have only two possible values, either 0 or 1. And if we are using two digits, combinations will be 4. So it can accept either 00 or 01 or 10 or 11. Two digits means we know for binary number system the base is 2 and the power is also 2. So 2 raised to the power 2 means 4. So maximum possible combinations will be 4. Similarly, if we are dealing with 3-bit, then it will be 2 raised to the power 3, 8. So that means 8 combination. So in that case, the initial value will be 000, 3 digits. So 000 and 8 combinations, and always it starts from 0. That means maximum value will be 7. So in binary, in decimal the maximum value will be 7, and in binary the maximum value will be 111. Likewise, if it is 4 bits, then it will be 2 raised to the power 4. Total combinations will be 16. So it will be from 0 to 15. So it will start from 0000, 4 bits, and it will end at 1111. So 4 ones. And that way it happens internally. So 2 to the power 8, we know it is 256. 2 to the power 16, this value. Then 2 to the power 15, 32, 31. Why I'm saying, because practically we will not use 2-bit or 4-bit. The compiler I am using right now, that has 32 bits, so it can accommodate 2 raised to the power 32. So this number, this is the maximum value it can accommodate. Though as a programmer we don't bother, whatever data we want to use, accordingly we declare the data type, and we process, and internally everything happens. But as a programmer, it will be always fair if we have a little bit idea about these figures. Now this table has extensive list of data types that C supports. As you can see, the details is given for 16-bit machine or 16-bit compiler. And here we have, let's start with integer. Now integer can be of two types, signed or unsigned. Like we may need plus 10 as data, or we may need minus 10 also as data. So if it is minus 10, then we also need to mention that minus sign, otherwise how that will be processed through our program. And that compiler also needs to understand, okay, this data is negative, and along with the value, the sign also needs to be processed, or that also has significance, and accordingly we have that provision. So if it is a 16-bit machine, that means 2 raised to the power 16. So what is that value? 2 raised to the power 16 is 65536. So this is the maximum value that that machine can accommodate. So if it is unsigned integer, means there is no sign, all the data will be positive always. So in that case, we don't need to reserve any bit for sign. So all the 16 bits can be accommodated or can be used for the value. Our count will start from 0 and the maximum value will be 1 less. So it will be 65535. Now suppose if we need to accommodate negative data also, we need to mention the negative sign also, then in that case one digit will be reserved for that sign, be it negative or be it positive. If it is only positive, then by default it will be taken as positive and we don't need to mention the positive sign. But if it is negative, then we, at least for negative data, we need to mention the sign. So one bit is reserved for sign. Then how many bits will be left? 15 bits. And what is that value? 2 raised to the power 15 is 32768. So in that case, the whole range will be divided into two parts. One half will be for negative data and the other half will be positive data. And as you have seen, 32768 will be in that case the maximum range. That's why minus 32768 will be the maximum value, or the maximum negative value that it can accommodate. So from minus 1 to minus 32768. And for positive data, since 0 is also a digit that we need to consider, so in that case our positive count will start from 0 and the maximum count in that case will be 1 less. Now suppose if we know beforehand that for any integer data the maximum value will never go beyond 255, then in that case we will not unnecessarily declare the data type as int, because if we do that, then it will occupy 16 bits in the memory. And for 256, we know 2 raised to the power 8 is 256. So it will occupy 8 bits only. So if it never goes beyond 255, then, and if we declare by int, then there will be always wastage of 8 bits. So for that, in C programming language, we have another provision for declaring integer data, and that is short integer or short int. So if it is again unsigned, unsigned means, so all the integer data which has lesser value will be positive in that case. And for that, the total number of bits that is occupied in the memory is 8 bits. And as I said, 2 raised to the power 8 is 256, and again it will start from 0, so maximum possible value will be 255. Now again, if it is short int but we want to process signed integer data, then in that case sign plays an important role and 1 bit will be reserved for sign. In that case, from 8, now the total number of bits that will be reserved for storing the values will be 7, and 2 raised to the power 7 is 128. So what will happen here is, again the whole range, which actually was 256 when it was unsigned, will be divided into two parts, 128 and 128. So the left, the first 120, first half, which will be reserved for storing negative data, that will store from minus 1 to minus 128, and the second half, which will be reserved for storing positive data, that will store from 0 to 127. So that is the concept of short integer. Now suppose if the data or integer data is more than the range that we know for normal integer data, then what we will do, we have again a provision that can store even the longer integer data, and for that the data type is long int, means long integer. Again we have two types, unsigned and signed, and in this case the bytes, the total number of bytes that it needs is 4. Each byte, one byte is equivalent to 8 bits. That means 8 4s are 32. So the total, if we are declaring any variable as long int, then in the memory it will occupy 32 bits. So if it is unsigned, then 32 bits, all the 32 bits will be used for storing values. Then 2 raised to the power 32 means this value. So it can accommodate for, or unsigned data or unsigned integer can accommodate 0 to that value minus 1. So it was 96. So it will be 96 minus 1. And if it is signed, then again the same concept. 1 bit will be reserved to store sign, and rest 31 bits will be reserved for storing the values. And what is that value? This value. Finally, it is 48. So the whole range again will be divided into two parts. The first part will store all the negative values from minus 1 to that value, and the positive half will store from 0 to then 47. Actually it was 48, then 48 minus 1. This is how what happens for integer data. And again we have two important data types, which is character and float. So for character, for 16-bit machine, it occupies 1 byte, means 8 bits, and it is single character, and internally first it maps with its ASCII code or ASCII code, and then finally it is converted to its binary bit stream, and that you have seen in my last class. So be it unsigned or signed, always it will occupy, the character data type will occupy 8 bits. But again the concept is same. If it is unsigned, then it will be 8 bits, means 2 raised to the power 8, so 256. So if it is unsigned, then it will be 0 to 255, and if it is signed, then again 2 halves. So first half will occupy or will store all the negative data from minus 1 to minus 128. This time it will be 2 raised to the power 7, and positive half, or the second half, will store all the positive values from 0 to 127. Now come to float. Float means the real values which can accommodate decimal point also. So float, if it is 16-bit machine, then float needs 32 bits to accommodate float data. That means 4 bytes. And as I said, float data type supports 6-digit precision, means after decimal point there will be 6 digits. And if in any calculation we need higher precision, then we have to use data type double. Double, what it does, or what is the difference, it only increases the precision, otherwise it has the same meaning. After decimal point it can accommodate 15 digits, but still it varies from compiler to compiler, but at least every compiler will support 6 digits that float supports. And the difference between double and long double is, again if we need even more precision, more than double, then we can use this long double data type. And as you can see, it needs, or it occupies 80 bits in the memory, and it has higher precision, higher than 15 bits, and again at least 15 bits it will support. Now this is all about 16-bit machine, and you can see here the number of bytes is written for 32-bit machine and 64-bit machine, and accordingly you can calculate the number of bits and the whole range of every data type, the minimum value, maximum value, for unsigned, for signed, everything. Now this is a simple program where I have used this library function size of, and when I have used this size of for every data type, from character, unsigned character, integer, unsigned integer, short, long, float, double, long double, it is actually showing that for my compiler how many bytes it will occupy for every data type. So for character, the first result here is 1. That means in my system character data type will occupy 1 byte, means 8 bits memory space, and character means signed character, by default it is. Then and for unsigned character also 1 byte. For integer it is 4. For unsigned integer also it is 4. For short int it's half, so 2. Short bit, signed or unsigned, it will be always 2. For long int it is 4 again. For float it is 4. For double it is 8, just double, precision is double. And long double it is 16. And this is a sample program where you can see I have used all the data types, and according to their range I have assigned values to every variable that has that specific data type. So with this I end today's class. Thank you.